So we'll continue where we left off with Mendel's experiment. So for simplicity's sake, we'll focus on one characteristic of the pea plant, and which is that this is the shape of the seed. So there are different kinds of seeds, and well, actually two kinds in this case, two different traits of the seed shape. So there'd be one smooth skin and wrinkled skin. Here's my wrinkled. Looks like a popcorn now, but it's wrinkled. Okay, so I have smooth, S for smooth, W for wrinkled. Okay, and before we go into the depth, I want to understand the very basic understanding and terminology. So we'll look into what's going on here. So if I self-pollinate, let me change color here so I don't. No, it's just this one. If I self-pollinate this guy, if I take its flower and I force it to pollinate itself, like take a paintbrush or a small brush, and then I pollinate itself, so self-pollinate, make sure it goes back together and goes in and it creates its own seed. Okay, and if all of its offspring have smooth skin, okay, all of them must be smooth skin, and this will be called true breeding. True breeding. Okay, true breeding, and these guys here will be known as true breeding plants. People would know true breeding as purebred. Okay, everybody knows what purebred is. A purebred dogs or so and so. So the book says true breeding. True breeding is the word that we use in the textbook. So something I don't want you guys to get confused. And the same thing happens if we use with the wrinkled ones. If you use the wrinkled guys, and if I self-pollinate themselves, different pollen going on, so don't confuse. Self-pollinate itself, and it has the same results of having all wrinkled ones. Okay, wrinkled popcorn shaped peas, seeds actually. Okay, and all of these guys, these guys here are purebreds, or true breeding plants. Okay, they're true bred. So also I want to say that just because I self-pollinate does not mean that's the only way. There's also, if I have a plant who happens to have smooth skin, and if I pollinate with that other one, let's have a red one here. If I do this, okay, it is also considered as pure breeding because they have the same thing. I want my red, yellow here. Okay, same thing. All right. So let's go to the next part, which is much more interesting. Okay, so I'm gonna remove this this guy here. Remove this layer, and then what happens if I take one true breeding plant, which is here, the smooth skin, and one true breeding plant, one of each, smooth and wrinkled. If I cross it and I make another one, we'll have a mix. Okay, this mix is known as hybrid. Okay, we all know what hybrid means. It means a mix. Now, since we're looking at a organism that has one characteristic that differs, one different characteristic. Oh, well, not one different characteristic. That one characteristic, like we're focusing on one characteristic that differs. If I understand what I'm saying here, just focus on one characteristic here, the shape of the seed, and we'll call this guy. Let's change color, so it's very important you go on this one. Monohybrid, because we're focused on one characteristic. Hybrid. Okay. Now I want to just get a little bit more terminology here, so to make you guys understand. I keep moving that. I don't know why. Come here. Okay. So this guy up here will be known as P generation. Okay. The P means parents or parental generation. I don't know for generation, but gen. P generation, and it's parental because they are the beginning. Okay. And their offspring, the first offspring, we'll call as. Let's change color here. Let's make it a little different here. I'll get some purple going on. And this guy would be F. Okay, F1 generation. Okay, F stands for Phyllis. Okay, which is Latin for son. Sorry, for son. And just like in French, the son is fils. There you get the idea of Latin involved. Okay, so Phyllis generation. So that's for. So if I do a cross with them, they'll also have an F2 and goes on. My F is all right. So like if I have the green F2 green F2 generation, these guys like this. Okay, see you next time.